in this presentation, we're going to discuss with what is a VMF, what exactly it can be implemented in different type of applications. So in various applications, we are going to discuss how VMF can be implemented and substitute the conventional HVAC system.
Welcome to Danvent's accredited professional program, where we aim to lead the green building industry through innovative HVAC solutions. This program is designed for sustainability professionals looking to gain a competitive edge in the field of green building certification. Our key focus is Danvent's VMF technology, a complete HVAC concept integrated with building management systems. It covers heating, cooling, ventilation, domestic hot water, and humidity control in cooling mode, all while ensuring high energy efficiency. Through this program, participants will depend their expertise in using VMF concept to meet green standards like H, LEED, and more. With VMF technology, professionals learn how to optimize building performance, reduce energy consumption, and enhance indoor air quality, all crucial elements in achieving sustainability certifications. The program not only offers technical training, but also provides marketing insights to effectively communicate the benefits of our systems to clients and stakeholders. Danvent's VMF concepts are versatile and designed to serve multiple sectors, including healthcare buildings like nursing homes, hospitals, and clinics. They are also ideal for retail spaces such as leisure centers, shopping malls, and supermarkets. Furthermore, our technology is a perfect fit for educational facilities, including schools, universities, and sports centers, as well as for office buildings or mixed-use developments combining office and retail spaces. After completing the structured training and certification exam, you'll receive an official accreditation, joining a network of certified professionals promoting VMF technology worldwide. This isn't just a technical journey, but a strategic one, empowering you to lead green building projects with confidence. If you're an architect, engineer, or sustainability consultant, this program offers a golden opportunity to stay ahead in the green building industry. With our global support and training resources, we are committed to making your journey towards sustainability impactful and rewarding. Ready to join? Visit our website to register your interest and get started on your path to becoming a Danvert accredited professional.
The second project that we will represent to you, it's a factory, it's an industrial project. What are the needs for this project? First of all, they needed a very large amount of cooling. They need a lot of ventilation, really a lot of ventilation, because in industry, the air changes ratio are quite higher than in the office building. So they needed cooling, they needed ventilation. This project is located on the seaside. So having a humidity control, also it's a crucial factor. And of course, being a factory, they also need domestic hot water, plus of course the space heating. So basically, for this project, they needed the 5 main functionalities: heating, cooling, ventilation, humidity control, and domestic hot water. The size of this project is quite large. As you can see, we have here 7 VMF units in total. And additionally to the 7 VMF units, we have 3 large ventilation units serving different parts of the production. One of it is for 13,000 cubic meters per hour, another 13,000 cubic meters per hour, another one 15,000 cubic meters per hour. So part of those ventilation units are supplied with hot or cold water through the buffer tanks of each of the subsystems. So for your information, our limitation is that maximum 3 VMF units can work in one hydraulic circuit, means 3 VMF units can supply to one buffer tank. And so in this case, we have 3 separate circuits, 3 VMF, 2 and 2. They cover the whole project, plus I repeat additional ventilation unit for the production. And then we also have here additional small ventilation units for the office part of that project. So we are basically doing the heating, cooling, and ventilation in the office buildings only with fresh air. For this project, very important is the cooling and the heating as demands, but also I repeat the ventilation because of the increased air changes ratio demands for industry. In the factory, we have industrial type fan coil units for high installation, which means above 5 meters. So the architecture here, it's a bit more complicated than the previous one. In this factory, the demands for domestic hot water were not so big. So normally we have a one domestic hot water tank with 1,000 liters covering the whole project. And here you can see that we have integrated also additional sun water panels because we are on the seaside. We have a lot of sunny days. So the domestic hot water system here, it's a hybrid between the VMF and the sun panels. So normally when we have sunny days, the master and the priority will be on the sun panels, sun water panels. When we are mainly in the winter time or in days where we don't have sun, the hot water will be produced from some of the VMF units. So again, this is a scheme for the industry. I repeat, quite large project, 7 VMF units, 3 additional big ventilation units, 2 additional small ventilation units, and with industrial type of fan coils inside the production, because the height inside is quite big, 5 meters. I will also share with you the energy analyzed for this project again, like with the previous one, to see the difference. It's on Bulgarian, but I will explain. Here we have 7 VMF units, additional 2 ventilation units, big ventilation units, additional 2 smaller ventilation units. So the total installed power input for this project, including the circulation pumps, is 207 kilowatts. Then the refrigerant, the total quantity of refrigerant with the VMF concept on this project is total of 83 kilograms, but all of it, it's outside the building, no refrigerant inside. On the right side, we have the classic system of VRF plus air handling units. So you can see a little bit, they have, in this case, we have 4 big air handling units. We have in total of 20 external VRF units, including VRF and multi-split. We have, again, 2 small ventilation unit. And also, very important fact here is because this is on the seaside and because it's a VRF directly supplying to the air handling unit, the air handling units must be supplied with backup electric heaters, which run very often. And the installed electric power for the electric heaters is additionally 150 kilowatts. So the total amount of installed power input for this project is almost 500 kilowatts, 2.5 times, almost 2.5 times bigger than with the VMF. The refrigerant quantity is also significantly larger, 373 kilograms. That's more than 4 times again a larger refrigerant quantity. So we show you a second project, completely different in terms of application, but the numbers repeat itself. Basically, more than 2 times smaller installed electric power input, and nearly 4 times, more than 4 times smaller refrigerant quantity for this particular project. I will go to the next one. The next one is also completely different project. It's a private home. Private home, quite large private home, more than definitely more than 1,000 square meter. And being a home, it's a multifunctional project, because inside we have inside this home we have a living area, we have a cinema, we have a spa and swimming pools, we have outdoors areas which needs to be conditioned. So very versatile project. I will try to show you here a real drawing so you can have an idea for this one. You can see this is part of the living area. This part is the spa with the swimming pool. These are external rooms outside of the main building that needs to be conditioned. So this is a very interesting and versatile project. This is how it looks from the top on the roof. So for this project, we have actually 4 units in total, 2 VMF units covering the cooling and the heating capacity, 1 swimming pool unit, dehumidification swimming pool unit additional to the VMF, and additional heat recovery ventilation unit for the external rooms that needs to be conditioned. So very interesting project. 2 floors, underground floor mainly with cinema and some supplementary rooms, and a ground floor with the living, basically with the living areas. So here also the internal design is very interesting. We have the chilled beams, but they are connected to a special type of grills. So again, very interesting project. I will show the hydraulic scheme. Here we have the demands. If we talk about the demands, are the same for every other project. They need all the 5 functionalities. They need heating, cooling, ventilation, humidity control. Again, it's very sensitive because this is a private home that is just probably 200 meters from the sea. So humidity control in summer is very important. Domestic hot water, of course, and everything is controlled with integrated BMS. For this project, we don't have additional sun panels. So the hot water tank will be supplied entirely from the VMF units. We have 2 VMF units connected to a 1 buffer tank. And from the buffer tank, we have circuits going to again to the water distribution board. But here you can pay attention. Very interesting for this project is to the VMF system we integrate underfloor heating system. So the whole project is covered with underfloor heating system. If I remember, for this project we have more than 9,000 meters of pipes for underfloor heating. So that part here, this water part, is integrated to our system. So this shows how flexible VMF is to external systems and how we can integrate them. So basically in the winter time, underfloor heating is working, and the chill beams are switched off, but the ventilation continues to work. Again, it could be a small project, but as you saw in this project, we have a very different conditioned areas, like demands. We have a cinema, we have living rooms, we have spa zone, many external zones to be covered. So very interesting and versatile project. Let me again show you the architecture is very interesting also. So we can, with this one, again, also on the underground level, we have the plant room here with the buffer tank, with the hot water accumulator tank. With this one, we just proved that VMF can also be part of the commercial type of application. The next project that we will share with you, it's also a completely different project. It's this project is a running project that we execute at the moment. It's a multifunctional swimming complex. This project is on 4 different levels, 2 to 3 levels under the ground. So we have here Olympic-size swimming pool, training swimming pool, kids swimming pool, so 3 swimming pools in total. We have also a fitness center. We have a spa zone under the ground. We have offices, we have cafeterias, we have dressing rooms, and basically this is again multifunctional project. What are the demands for this project? The demands are very different here, because the priority in this project it's obviously the hot water. But in this project, the hot water is needed in many different sub-applications. We need a lot of hot water, obviously, for showering after swimming. So domestic hot water is a huge priority. But hot water for the swimming pools itself, it's also a big priority. And also, we have half of the project is covered also with underground floor heating. So we also need hot water there. And you can see that in this particular project, we have integrated 2 extra systems. We have integrated a very big sun panel system. This sun panel system actually covers the total demand for domestic hot water, 2 big hot water tanks, but also it covers the hot water needed for the swimming pools in the intermediate modes, which means spring, fall, and summertime for the training swimming pool and the kids swimming pool. So I repeat that in this particular case, some water system, it's a priority system, very important, covering domestic hot water and hot water for the swimming pools in intermediate modes and summer modes. Then in this project, we have 3 VMF units covering heating, cooling, ventilation, humidity control, and also serving as a backup for domestic hot water to the main sun water system. All the 3 VMF units in this particular project are supplying into one central buffer tank. And from this buffer tank, through the water distribution collectors, we go to the very different zones. We supply underfloor heating in different zones. We supply the chill beams, the heating, cooling, ceiling panels, and we supply also water for the VMF supply coil itself. So this one, in terms of both size, complexity, and additional integrated systems, is a quite big and complicated project. Additionally, it is not shown here, but additionally, for the swimming pools, there are two big swimming pool dehumidification units. So again, it's a quite large project, but in terms of complexity, it's very complicated because we have 3 VMF units, we have some panel system, we have underwater heating, underfloor heating system. We have a lot of, as you can see, domestic hot water tanks. These two. We have buffer tanks. We have a lot of pumps, sensors, 2-way, 3-way valves. So everything is controlled here from a so-called master controller that will tell the units how to work exactly in the different scenarios. So this one, hopefully, for some of the next training session, we can show it with a real photos, because I repeat, this project we are executing it at the moment. And the last project that we want to show to you today, it's also very different as an application, but also as a size. It's a hospital, a very big hospital, and very different in terms of reliability, because hospital is a completely different type of project comparing to all the previous ones. So the initial design, this is a very big project, the biggest one we have designed by far. It's a 8-floor building. What you see on your screens are this is the initial design with, here it is, with the VRF units, here also VRF units, and a lot of fresh air handling units, and the architecture for the classic VRF system with internal cassettes. Also, there are additional, on each floor, additional heat recovery ventilation units for the fresh air. For this particular project, if I remember, because we designed it a year and a half ago, we have 7 to 8 surgery rooms, so quite big. So we completely redesigned this one, and I will show you now how it looks. So for this project, we have totally of 11 VMF units totally on the project. 11 VMF units that are located on 2 different levels. We have actually, just a second. Actually, are 15 VMF units. 11 VMF units are on the roof, and 4 VMF units are on the ground floor. So what is the architecture for this particular project? For most of the floors, actually for all the floors besides the last one, where the surgery rooms, we have the 2 VMF units covering one floor. If I remember correctly, one floor was nearly 1.2, 1.4 thousand square meters. So for each floor, we have 2 VMF units with one hydraulic, with one plant room per each floor. So as you can see, the units on the roof through a vertical openings are supplying both ducts and pipes to each floor. So this is the different levels. So as you can see here, we have 2 VMF units per each floor. The demands for this project are quite obvious: cooling, heating, ventilation, domestic hot water. It's a big priority here, and of course, the BMS system. It's very important because it's a very large project, and we have designed it in a way that it's very simple but very reliable. The difference with the previous project is in this particular one there are no additional integrated systems, like there are no sun water panels, no underfloor heating. But the interesting part in this project is that the domestic hot water tanks are all located in the underground level. They're all here on the underground levels. So on each floor we have only the buffer tanks on each floor. For each floor in the plant room we have 2 buffer tanks, 1 master and 1 backup buffer tank, just for reliability. And as you can see, the 4 VMFs on the ground floor are covering the ground floor 0 and minus 3.8 level. So all the domestic hot water is located in that part here. The numbers for this project are even bigger. This is our comparison analysis on Bulgarian, but I will show you that the refrigerant quantity in the original design with the VRF units was over 700 kilograms. From over 700 kilograms, we go down to 230, almost 3 times. Very important, the installed electric power input in the original design with the VRF was over 800 kilowatts, and we went down to 350, which again, it's more than 2 times less. Also, this was also in the original design. It's a water system, so we reduced more than 3 times the quantity of propylene glycol for the whole project. So the bigger the project is, the bigger the number are, and as you can see, the difference is still very big, 2 to 3 times in terms of installed electric power, in terms of refrigerant quantity. So all these projects that we have shown to you today were important to give you an idea that VMF can cover just any type of application and any type of size of the project, and also it can be installed to any point of the world without temperature limitations. And if you're further interested in some particular applications, we can go in more details and show you how it works. But in generally, I repeat that in generally, what we do when we have a potential project is what we do, the so-called pre-design that I showed you on the first project. This is how it looks, the pre-design. We give the internal units, the duct parts, the water part, the principal scheme, plant rooms, and everything else. And at this level, we also provide a general budget based on this pre-design. Plus, don't forget the comparison analyze, which we do for each project. So I really hope that all these projects now gives you the idea that we can really cover any application, any size of project at any location in the world. Yeah. So yeah, thank you for your time. I repeat, if you have a specific interest for a particular project application, we can go much deeper with details. Blaise?
Okay. Yeah, thank you very much, Dan. Thank you. Yeah, thank you for covering everything. Yeah, I think the application went really well, very excellent. Yeah, and then we don't need to kind of I don't know. After maybe few quick questions I will ask. I don't know is appropriate time, but we can cut it any time. It's not a problem. Yeah, we combine on the floor. We combine on the same application. Since on the floor heat is 35, like around 35, maybe 40 degree working condition, and the room. You combine the two, the chill beam and on the floor heating on the same project.
Yes.
I noticed that.
Yes, you're right. The chill beams normally working between 32, 33 as a minimum, up to 40 degrees of water. Underfloor heating normally is down with probably 29 to 33, depending on scenario. But the underfloor heating is just taking hot water from the buffer tank. But with the three-way valve and with the circulation pumps, the underfloor heating system manages the exact temperature they need for their system.
Okay.
It's very simple.
Okay, thank you. Just in case if somebody have a project, what is supposed to provide as initial data for
project for the underfloor heating?
Yeah, no, for the project, for generally in project, if you want to.
For general project, we always need and we always start with architectural layouts, and then it would be very useful if, together with the architectural layouts, if they can send us a small sheet or explanation that we have a description for every room, every floor, how many rooms, how many people in each room, floor area and height per each room. This, if they can extract this initial information from the architectural layout, this would be perfect. Of course, if for the particular project, if they have cooling loads, heating losses calculated, that would be perfect. The pre-design.
Okay. Anybody have a good project you want to check if the VMF already is suitable for that, because like I mentioned, you need to make sure that what you are looking for, the minimum full functionality might be used from the VMF. That will be very cost effective for your project. Basically, less than that, you can see this picture is one of the VMF already installed in one of the projects that who's currently working perfectly. So the VMS is working. We're not in the prototype stage. We're in the scale up stage. So we're looking for project who want to achieve high energy efficiency, and then also we are looking to save mostly operational costs. because this you can scan the code here and submit your project. You can even do that later because it'll still be online. So we are open to one-to-one support for you. We can give you one-to-one support, or you're even welcome to visit the factory, and to visit the project or any project site that what we implemented already VMF. So we are not just here to sell or maybe talk about technology. We want to raise your awareness about the paradigm shift we are bringing in the HVAC world. So if you submit your project today, the support, you have full technical support. We provide you turnkey proposal using VMF technology. So like I also mentioned during the presentation, we have 100% full responsibility. So we don't just provide technology, we support you up to the installation and even operational phase. So we make sure that technology works. So we provide turnkey with the full responsibility. So please don't let this opportunity pass by. Prepare your submission now and then scan this QR code and submit your project. So we'll be happy to support you. Yeah. What this for? We are looking for architect with who are looking to for a simple system, elegant to integrate us current project. It might be also an engineer, HVAC engineer who are looking for alternative solution. Who are mostly open mind engineer who want to develop, who want to look at new approach, a new opportunity in the UK or maybe in Africa. We are more than welcome. We are also open to other places of the world as long as it's open-minded developer or engineer architect who are looking to implement new technology, who can let them to achieve high energy efficient. We're also looking for edge expert or project owner who are looking for very efficient technology for the project. Yeah, if you are committed to building a smart, greener future, this is your moment to lead the change. You can implement VMF your project. I'm sure you will be happy and you will recommend us. We don't follow trend. We develop a solution and concept. It's a new concept. We cannot develop a new universe of HVAC system. We think we really make a big change. Okay, thank you again. Thank you for your time. If there's any question, you can drop on the chat because already past the 75-minute marks. So you drop your question on the chat. I'll be happy to answer and give you my comment. There's any comment to make. Oh, thank you again. Thank you again. Thank you for your time. Thank you for those who found the time on the busy schedule to participate at this masterclass. And also, yeah, you see the video seen online. It's on live. You can still share with your colleague, share with people that have interest, who are project, who are looking for energy efficient, want to save money, mostly on the OPEX side. Yeah, hotel, hospital project, office project, or hospital, all those. Residential. It might be also be retail center, office project, hospital.